Hi, everyone. Thank you. So my name is Ran, and I'm a specialist solutions architect for AWS. I specialize on Spot instances. That means that I get to work with customers on architecting cost-efficient, resilient, performant applications using Spot instances, and of course, many different types of workloads, such as containerized workloads. I talk a lot about Kubernetes and ECS, and of course, stuff running on EC2, and analytics and big data workloads, which is what we'll be focusing on today. In this session, we'll go over how to kind of use EMR and the best practices of Spot instances to run your data processing workloads. I'll start with a quick recap of EMR and then walk you through Spot instances just in case you're not familiar, and kind of the changes and the best practices that you need, and then how to hook those two things together. And I'll mostly be focusing on Spark within EMR because that's what mostly we're seeing today. But the best practices that I'm going to talk about are also eligible for kind of other stuff that you can run on EMR, the other frameworks that run on EMR. This is a demo, so this is the only slide I have for you today, but I'll do some talking and then we'll get to the actual demo with EMR, instance fleets, and Spot instances. So just in case you're not familiar with EMR, it's a managed service for running big data processing frameworks such as Spark, Hadoop, Presto, Hive, all those different things. And you can run them on EMR very easily just by specifying what kind of cluster you want to bring up and what kind of applications you want installed on that cluster. And then the other best practices that we're seeing customers achieving with EMR is actually that decoupling the compute from the storage, right? When you don't need to have your data set that you're going to do the data processing against on the HDFS on the actual cluster, on the actual compute cluster, and you can have it on S3, that taps you into that capability of decoupling compute from storage and actually running those EMR transient clusters. And then depending on the use case, maybe you're a pretty advanced organizations with those advanced data processing pipelines with dependencies, and you're maybe using something like Apache Airflow to use with DAGs. So then you can tap into EMR within those DAGs to bring up a cluster, do the data processing, hopefully cost optimize that data processing with Spot instances, which I'm going to show you how to do, and then shut down that cluster. You don't need to have that cluster up because your data is on S3. And of course, all the capabilities and benefits of S3, super cheap object store with very important capabilities for data lakes. For example, different price tiers where you can automatically put your data in cheaper storage tiers when it gets colder. So all those benefits of S3 and EMR taps right into that with EMRFS, which is a drop-in replacement for HDFS. So your data is on S3, your data processing is done easy with Amazon EMR. And then to cost optimize, you'll be looking at, to cost optimize further, right? You're already cost optimizing by not running the cluster all the time. To cost optimize further, you look into EC2 Spot instances. And what those are is Spot instances are the spare capacity that we have in EC2. So we allow customers to use that spare capacity at up to 70 to 90% discount. But those instances can be taken away with a 2-minute warning once we need that capacity back. So if you're not experienced with Spot instances, you might be thinking to yourself, okay, but will my workload fail? Will my users fail? Like, will I have availability issues? So no, we work on architecting workloads that will be fault tolerant and stateless in a way that even if some of our capacity goes away, our workload still continues and works on. So this is relevant for a lot of different types of workloads. For example, if you're running an application like an API endpoint or a website on EC2 behind an ELB, you can simply use an auto-scaling group to specify the instance types that you can use with Spot instances. And if some of that capacity goes away when EC2 needs the capacity back, auto-scaling group is just going to bring you other capacity, like a different instance type or from a different availability zone. So actually tapping into multiple Spot capacity pools allows you to achieve that capacity and stay resilient in case there are interruptions. And EMR instance fleets allows you to do exactly the same thing, and I'm going to demo that in a few minutes. The first thing I want to show you is how Spot pricing works. So just in case some folks in the audience used to use Spot pricing up until a couple years ago, before we actually changed our pricing model, now you can see that the Spot pricing model is pretty smooth, so we don't have any spikes in the pricing. This is the Spot pricing history tool that you can find in the EC2 console. And what I'm showing you is the R5 XL price for the last 3 months in the Ireland region. We had a very small price spike here which is common. What we're actually seeing here in the yellow price change is one of the AZs went from basically 8.3 cents up to 8.7 cents and then back. So spot prices are much more predictable today. So if you used to use spot pricing up to 2 years ago, you'd know that that was quite different with spikes. We don't have that today, which means that you also don't have to think about bidding, right? So if you know spot as a bidding mechanism, that's no longer the case. You just ask for the capacity. You don't have to think about bidding at all. That's just not a part of the mechanism. And you get that capacity once we have it. And the way we think about tapping into spot capacity is by different capacity pools. So even here, if you look at the R5 XL, we have 3 capacity pools with different prices, and the on-demand price is 28 cents per hour, and then you're seeing quite a significant discount for the spot pricing here. But if your workload runs okay on an R5 XL, you can probably use other workloads, for example, an R5 2XL, which also has pretty smooth pricing changes. But then you might be thinking to yourself, if I'm running Spark on I kind of qualified an R5 XL, I know what my Spark executor size is, what's going to happen if I get a 2XL, right? Am I going to waste all that capacity, all that processing power? So no, what we recommend is to actually right-size the Spark executors. So if you get an XL instance, you run one executor, but if you get a 2XL instance, you actually be able to run multiple executors, like 2 executors, depending on the size of your executors. So what we're talking about with EMR instance fleets is actually tapping into letting EMR know which instance types you're able to use and allow EMR to choose the instance types from the instance types where we have the most capacity. So that means we're decreasing the chances of your workloads getting interrupted by EC2. The next thing I want to go over is right to actually creating an EMR cluster. And I'm showing this via the console, but everything, of course, is, as always, available programmatically, whether you have data pipelines with, like we said before, Apache Airflow, or you're using step functions to kind of orchestrate your data workloads, or you have a more humble data processing pipeline where you just do something every night, kind of data crunching every night on your data in S3 or things like that. So I'm going to start with just selecting which applications I want to use on my cluster. I'm just going to select Hadoop and Spark, which I'm going to run a Spark application later on, and Ganglia because I want to get some monitoring insights into my cluster. I can run an EMR step here, but I'm not going to do that now. I just want to get to where the magic happens, so to speak. And there are 2 configuration options for EMR. The basic one, which existed for a long time, is the uniform instance groups. But what I want to focus here is EMR instance fleets, which allows you to tap into that, to those spot best practices of diversification and deepest capacity pools that we talked about before. So the first thing I'm going to do is actually specify to EMR all these 3 availability zones. And if you're using EMR today, you might raise an eyebrow and saying, hey, but EMR only works in a single availability zone, so why are you kind of choosing subnets in different availability zones? So yeah, EMR is still going to start on one availability zone in order to prevent that data cross-AZ data transfer cost that we want to avoid. So EMR is still going to start in a single AZ, but it's going to find the best availability zone to run your cluster in. And I'm going to choose, the next thing I'm going to do is select my instance types. And according to those instance types, EMR is going to look across all those availability zones and find where the best capacity is for my cluster. So I'm going to start with the task fleet. And if you're not familiar with EMR, we have 3 different types of nodes in EMR. So we have the master, the core, and the task. The master is the node that actually manages the cluster, monitors it, and makes sure that the cluster is healthy. And then the core node would be a Hadoop slave, right? But this would have HDFS on it. And the task node is where the best fit for Spot instances is because there is no HDFS data on the task nodes. So you can just run your Spark executors on the task nodes. And if some of that capacity goes away, Spark is inherently fault tolerant. It's just going to retry and continue running your job. The job might take longer, But the message that I'm trying to convey here is that via that flexibility of availability zones and instance types, my nightly cluster might start one night in one availability zone with one instance type, the next with another. But overall, I'm operationally healthy and I'm running those data processing pipelines without any impact on my final workload, right? So I'm saving a bit differently every night, and my cluster might run with different performance every night, but eventually I'm going to be able to meet my SLAs and with deep cost savings. So what I'm going to do now for the task fleet is, just because we know that customers love high memory instances for Spark workloads, just because of how it's the sizing of the Spark executors normally fit on our family instance types. I'm just going to choose our family instance types from different flavors and different families. So I'm going to select an R4 XL and 2 XL, and an R5 XL and R5 2 XL, and also an R5, for example, an R5 with an AMD processor, R5A XL. So what's happening here, what I can see here now is that I have my task fleet set up with multiple instance types, right? So like we said before, if EMR chooses a 2XL for my cluster, will I waste some of that processing power? No, I'm just going to run 2 executors on that instance type. And I'm going to specify the total spot units, the total units that I want to run in my cluster. So we're kind of, in order to allow that flexibility, we're moving away from the number of instances that we're going to run into the number of units that we're going to run. And the units can be anything you decide. What we put here by default is simply the number of vCPUs that instance has. So the R4 the R5 XL has 4 vCPUs. So this is worth 4 units towards my total target capacity, which could be 300, for example, right? And then EMR is going to fulfill the number of units that I asked for it according to the best instance types that it can. So it's either going to be a certain amount of R5 2XLs, a certain amount of R5A 2XLs. So it's just going to select the deepest capacity pool for this. The other interesting option I want to talk to you about is the ability to set up a provisioning timeout. So if for some reason EMR is unable to get capacity from any of those instance types across any of the availability zones, which is pretty rare because I set up a lot of options for it. I gave it 3 availability zones, I gave it 5 instance types. It's probably going to be able to find my capacity. In case it doesn't, I can tell it to either terminate my cluster or switch over to on-demand instances instead of Spot. And you determine this according to the type of workload that you're running, right? In case you have a very strict SLA workload and you have to finish that job, you might fail over to on-demand. But if you're okay with that job completing later or retrying it, then you might want to say, hey, terminate my cluster. I'm going to finish that work later. So for the master node, I'm just going to leave an on-demand instance of an M5 XL, and I'm going to run another couple of executors on my core nodes, actually. So I can just specify that I want XL instances for my core nodes. Let me just get the M5 out of here. It's not a good fit because it's not a good fit for my Spark executor size, which I'm going to talk about in a minute. And then I'm just going to run 4 units of one of those instance types, which means one instance will be provisioned here. So I'm just going to go ahead and run my cluster. I'm just going to tag it as a best practice. And I'm launching my cluster. Now, just like in cooking shows, this is going to take a while, so I already have one cluster ready from before. And I'm going to show you how to run a job on that cluster and how Spot instances were leveraged in that cluster that I started before. So as you can see, this is my previous cluster from a couple hours ago. The hardware configuration, the instance types that I configured are pretty similar. I basically selected the same thing. And I can show you if I grab the actual name tag of this cluster and go to the EC2 console. Actually, I already have it filtered. So these are all the instances that EMR started for this cluster that I started a couple hours ago. And this would be the master, the core, and what EMR selected in this case is the R5 to XL for this cluster. It found that this instance type has the best capacity, so it just selected this instance. My new cluster might select something else depending on the time and the variability of our capacity pools. So what I can do now is show you how when I run a step on this cluster, different sized instances would run a different amount of executors. So I just had a few steps that I ran on this cluster before, and an EMR step is kind of an easy way to use the EMR API to run, for example, Spark submit jobs. So this is actually going to run, as I'm just going to show you, I'm going to clone this step, and I have a Spark application here. I'm just going to do Spark submit, and I'm actually setting up my executor size here. Why is this important? This is important instead of using maximize resource allocation, which will actually let EMR use all the capacity in the cluster for that type of flexibility, right? I know now that if I run an executor with 18 gigs and 4 cores, this is going to fit on any of the R3, R4, R5, all the new R5 flavors with the local storage and AMD. So I'm pretty flexible in the way that I can run these workloads. So this executor will actually be able to fit in a lot of those instance types, as well as i3 that has the same 1:8 vCPU to memory ratio. So I'm staying pretty flexible if I use this. Also keep in mind that if you're going for very high memory executors on Spark, you might be facing garbage collection issues, so slowing down your jobs even further. So keeping to those smaller instance types is kind of a best practice. Also, I want to show you, in terms of keeping to smaller instance types, this is a tool called the Spot Instance Advisor. This is available if you just search for Spot Instance Advisor. And what it's showing here is the interruption rate for the last 30 days in all of the instance types in this region. So two takeaways here are that older instance generations are generally less interrupted than current instance generations. So if we look at the R4 family, a lot of these instance types are interrupted less than 5% a month. So you can kind of get an idea about how Spot instances can be interrupted, but it's not like they're interrupted all the time or every few minutes. You can absolutely run very resilient applications on Spot instances, which is something that a lot of our customers are doing. And if we look at the R5 family, we're seeing a bit more interruptions here. This is still manageable. You can still use these workloads. But the takeaway is that previous instance generations have lower interruption rates, and also that smaller instance types have generally, in the memory instance types, the R family, smaller instance types have lower interruption rates. So if I stick with my cluster to XL, I might not be seeing any interruptions at all, right? Which is great because I have consistency in my job runtime, and it's just going to be a great instance type to work with. So now I have a few minutes, and after I submit this job to the cluster that I ran previously, I wanna quickly look at Resource Manager, but I don't have access to Yarn Resource Manager, so I'm just going to fix that real quick. If you're watching this on YouTube, don't try to hack the cluster. It's already down, by the way, by the time you watch this. Yeah, so now I have access to Resource Manager. I'm just going to go over to the Nodes section. And what I can see here, that I submitted my job, and I'm going to see in any second now the job coming in. And this is still in pending mode. So I'm going to see the job coming in. So now the Spark driver is running here. You can see one container on the core node. So on the core node is actually running the Spark driver now. And any second now, actually, yeah, here we go. Demo guards are with me. So I'm actually seeing 2 executors running on my R5 A2XLs, right? So I set up, so I'm going to have a very performant cluster here. I'm actually running 2 executors on each one of the instance types that EMR selected for me. So I'll be able to run very performant, resilient clusters on this EMR selected instance types that are least likely to be interrupted. It's using all the the memory and the vCPUs on those instances because I right-sized my Spark executors, and this is really a great way to do data processing with Spark on EMR. The last 2 things I want to show you is a blog post on the EMR Big Data blog, which kind of covers these best practices that we talked about. So if you just go to the Big Data blog, which is a good read regardless, the EMR team also reports here about a lot of the optimizations that they're doing with Spark, and they're actually making a lot of optimizations and pushing them back to open source. So it's a really good, great read, the Big Data blog. And this has all the kind of the best practices that we talked about in this session. And the last thing I want to show you is a workshops website for Spot instances. So if you and your organization has interest in leveraging and adopting Spot instances into your workloads, we have a website called EC2 Spot Workshops. Just use your favorite search engine to find it. And what we have here is different types of self-paced kind of labs and workshops, which allows you to leverage those best practices and see step by step how to bring up those workloads. So for example, an ELB type workload, we're running an API endpoint or a website, and then we're going to catch the spot interruption, which will come in through CloudWatch events, detach the instance from the ELB and from the auto-scaling group to continue being the resilient to the workload. And the important thing to this session is we have a workshop for running Spark applications on EMR, and we're touching on very important things here, pretty prescriptively, like how to right-size the Spark executors in order to leverage these best practices. And some other cool stuff, like you'd run an Athena query against the application that you're running here to verify the application's results, and then you're also going to analyze the costs that your workload ran on. So using Cost Explorer, how much did my Spot instances cost? How much did my EMR cost? So definitely log in to EC2 Spot workshops if you want to go through this self-paced workshop. I'm right on time. I'll be here around if you have any questions, and thank you for attending.